The demand for networking resources is growing at a tremendous pace, fueled in no small part by the demand for internet resources. Good network design will allow your organization to meet this demand now and be able to accommodate future expansion. Let's take a look at hierarchical network design. It's easier to think of a complex topic, such as network design, as a series of layers. With network design, we look at 3 layers: the core layer, the distribution layer, and the access layer. This 3-layer approach can scale to meet almost any level of demand. At the core layer, you have high-capacity routers, such as the Cisco 7000 series. The core layer is concerned with providing fast connectivity between points at the core layer. Core layer routers carry information about all the routers in the network. Routers at the core layer typically connect to each other at T3 speeds or above, and often use SONET or synchronous optical network, which can support speeds approaching 20 gigabits per second. These are the big pipes of the WAN and are usually leased from a telecommunications service provider. Core routers need to have multiple redundant paths to other core routers to be able to withstand outages on individual segments and to share the loads between these paths. If one of the core routers goes down, a large portion of the network is affected. Core routers also need to use routing protocols with rapid convergence, like OSPF. The links between core routers are concerned with efficient use of bandwidth. You don't want to place access control lists or ACLs on core routers. That would slow down packet processing, and these routers have a lot of packets to process. Additionally, you don't want to place servers or hosts at this layer. The distribution layer uses medium-sized routers such as the Cisco 4000. Distribution layer provides network services to multiple LANs within the WAN. In addition, multiple buildings in campus settings are typically joined by distribution layer routers. Routing between VLANs, access to the core from LANs, and security provided by access control lists is handled at this layer. We say that the distribution layer uses policy-based traffic control to ensure the best performance for time-dependent mission-critical systems. Policy-based connectivity prevents unnecessary traffic from reaching the campus backbone. Servers and hosts are not placed at the distribution layer to keep that traffic off the backbone as well. The distribution layer routers need to be able to select the best paths to different locations within the WAN in order to make efficient use of bandwidth. The access layer is the point at which LANs, such as Ethernet or token ring networks, are able to connect to WAN resources, such as the Internet. Routers such as the Cisco 2500 and 1600 series are used at the access layer. End-user computers and servers are connected to the LAN. The access layer lets us segment the networks and groups of users based on their function, such as the marketing department and human resources department. We place access control lists on the router at this layer in order to prevent unnecessary traffic from reaching the backbone at the distribution layer. Routers at this layer control traffic by localizing broadcasts and service requests to the area in which they are required. Access routers need to provide connectivity but not compromise network security. For example, a telecommuter dialing into the network must be checked to ensure that they are a legitimate user. We have to ensure that the process of logging on remotely requires a minimal amount of steps by the authorized end user. Not every network needs to be designed using all 3 layers. In some instances, such as branch offices that need to be connected to a corporate WAN, a 1-layer approach may be more appropriate. A 2-layer design would feature 1 or more access routers connected to a router at the core layer. Each of these access routers may connect to 1 or more LANs at each site. The goal of using a hierarchical network design is to control and contain network traffic to provide the most efficient use of the available bandwidth. Remember that your LAN and WAN usage will increase over time. Careful planning at the start will provide good use of resources now and in the future.